Alrighty, so 6.2b lesson, we're looking at scaling triangles. So for the very first few there, it says, let's revisit triangle ABC and PQR from the previous lesson. For number 1 through 8, use the figure to the right to write each ratio as a fraction in simplest form. All right, so BC has a 2 by it. QR has a 6 by it. So 2 to 6, it says write it as a fraction. And then in simplest form, 1/3. Okay, we're going to do the same thing for all 8. AB is 7. PQ is 21. And that simplifies to 1/3. AC is 6. PR is 18, and that also simplifies to 1/3. Okay, the perimeter of ABC. ABC is going to be 2 plus 6 plus 7, so that's 15. And then 6 plus 18 plus 21, 45. That also simplifies to 1/3. BC, 2 to AB, 7. That is already in simplest form. AC is 6. AB, 7. That is already in simplest form. AC is 6. BC is 2. That simplifies to 3 or 3 over 1. RP is 18. QR is 6. That also simplifies to 3 over 1. All right, it says in number 9, some of the ratios above make comparisons of measurements in the same triangle. Other ratios make comparisons of the measurements of corresponding parts of 2 different triangles. Put a star by the ratios that compare parts of 2 different triangles. What do you notice? All right, so my stars are going here. There's a small one and a big one, a small one and a big one, small one and a big one, small one and a big one. These are both the smalls. These are both the smalls. These are both from the small, and these are both from the big. Okay, so I'm just starring those first 4. Okay, what do I notice? The ratios of all those 1 starred simplify to 1/3. The ratios of all stars above simplify to 1/3. Oops, sorry guys, let me scooch that up. The ratios of all the stars above simplify to 1/3. All right, some definitions. We've definitely seen these definitions before, but I don't know that we've written them out just point blank like that. So ratio is a comparison of 2 quantities. I think that was in the very first, if not second lesson of this module. Okay, so let me give an example of that. In a bag, there are 6 red marbles and 4 blue marbles. The ratio, I want to put the simplified ratio. Simplified ratio of red to blue is 3 to 2. And remember, we've talked about writing it as a colon or writing it as a fraction, 3 over 2. It's the same thing. Usually I write with fractions because that's kind of where our module's going. All right. We've talked about writing it like that, or we've talked about writing it like that. They mean the same thing. You pick. All right, that should not be anything new. We've talked about that in a prior lesson. I think the definition was handed to you in a prior lesson from section 1. Okay, scale factor, we just started talking about on the last lesson. Okay, it's the factor that moves one figure to the other. Okay, so I'm going to reference the triangles that are up at the very top right of this paper, the scale factor, and a lot of times just for shortcut, I'll do SF just because I'm lazy. Nothing official. Scale factor SF, okay? That's just a Newman thing. That's not a for reals thing. Okay, the scale factor for triangle ABC to triangle PQR is 3/1 or 3. Okay, it's also important to mention that the scale factor of triangle PQR to triangle ABC is 1/3. Okay, it's really important to start understanding, if you haven't already from the last lesson in homework, that depending on if you're moving from the big one to the little one, if you're shrinking, something needs to happen. We're going to talk about that this lesson. Okay, if you're moving from the little to the big, that's the opposite way, just like we talked about right here. Something needs to happen. Okay, so you should be thinking about what that something is as we're starting to unfold that in the next couple pages. Okay. All right, the ratio of little to big is 1/3. The ratio, okay, this is key, little to big, okay, the ratio. But the scale factor from the little to big is 3/1 or 3. Okay, the scale factor. It's very important to understand that difference between the two. Okay, when you talk ratios, little goes, the first thing goes with the first thing, the second thing goes with the second thing. Okay, but if you're making something little to something bigger, you better be multiplying it by something larger than 1. Think about that. We're going to explore that thought in a second. All right. Since corresponding parts of the same ratio, there is a scale factor from ABC, triangle ABC to triangle PQR. The scale factor is the number you would multiply a length by in triangle ABC to get the corresponding length in the triangle PQR. What is the scale factor from triangle ABC to PQR? So remember, ABC was the little one, this was the little one, and this was the big one. Okay, so if you look back at your notes, last page, you would multiply all the little sides by the number 3 to get the equivalent, okay, the similar, I should say, sides on the big one. Okay, what is the ratio from the little to the big? Well, the ratio is 1/3. Remember, ratio has to stay in the order that it's given, small to big. It better be the smaller number and the bigger number in the ratio. Scale factor is different than ratio. You need to understand the difference from this lesson. That's one big takeaway. What is the mathematical relationship between the scale factor of triangle ABC to triangle PQR and the relationship from triangle ABC to triangle PQR? Okay, so we're comparing scale factor and we're comparing ratio from small to big, small to big. Okay, they are reciprocals. All right, what is the scale factor from the big one to the little one? The scale factor from the big one to the little one, if we're shrinking, we better be multiplying by something less than 1 on every side. Remember, we're thinking of multiplying, we're not thinking about dividing by. So if you look back at PQR, you might think if I divide all those side lengths by 3, I get my lengths of ABC. Please do not be thinking in terms of division. Be thinking of what you're multiplying by. Scale factor is what are you multiplying by to get to the other figure. Okay, what is the ratio from PQR to ABC? Well, the big one went with a 3 and the little one went with a 1. Okay, what is the mathematical relationship between the scale factor of ABC to PQR and the scale factor? So now this is comparing the scale factors of little to big and big to little. They are reciprocals. Okay, this number 11 and all of these, I put a little star, let me scooch it. I put a little star by number 11. If you understand number 11, you are getting all the relationships that you need with scale factor and ratio. Okay. What would happen to the image if the scale factor is 1? Okay, if you're multiplying a shape's side lengths by 1 to get the other one, hope you're thinking it's going to be staying the same. Okay, so the new image would be the same as the original. What would happen to the image if the scale factor is greater than 1? Okay, well, if you take a triangle and you multiply all the side lengths by a number that's bigger than 1, don't you think you're going to be blowing that triangle up to a larger image? You need to understand this. Is 1 and then is greater than 1 and is less than 1. These are key. Okay, this page is key. Okay, so if it's greater than 1, the new image would be larger than the original. What would happen to the image if the scale factor is less than 1? If you have an image, a triangle, and you take all the sides of that triangle and multiply it by some number less than 1, that means you're multiplying it by a fraction that's smaller than 1. Wouldn't you be shrinking the object? Okay, the new image would be smaller than the original. Okay, so it's really important to understand that, and that. That is super key. This page, super key. All right. Use a straight edge and a protractor to duplicate triangle ABC, then construct a new triangle, triangle DEF, that is the same shape as ABC, but the scale factor from ABC to DEF is 2. Okay. So again, something happens when a Word document goes to a PDF and then gets printed. Sometimes if you measure this might not be 4 centimeters. I'm going to take a look and see. It actually is. Okay, so we're going to make a 4 centimeter. Let me scooch that up a little bit. Let me scooch the whole paper up. I'm trying to juggle this thing hitting this base. And okay, so I've got 4 centimeters right here. Okay, I start by measuring the longest side. Okay, now I'm going to come in here and I'm going to measure this angle right here. And I'm going to need something to project it a little longer. Let me get this little notepad here. I think will do the trick. All right, so I'm seeing that guy as like 30, 38, 37, something like that. Hold on, let me put it exactly on it here. Okay, there. All right. Yeah, I'm seeing it about 38. Okay, so I'm seeing this about 38 degrees. Let me just measure this guy in the corner over here. And I'm measuring this guy to be like 26-ish. Okay, so now my duplicate, I need a 38 degree angle right here. So 38 is like right about there. Okay, so I'm going to take my straight edge here and I don't know how long, I need 2 centimeters. So I don't need to go that long, but I just need to line up this vertice through these dots here. And I'm just drawing a line. Okay, I know that I just measured this to be 38 degrees. Okay, now I need this to be 2 centimeters. So, okay, I'm just going to start my measuring at 20 because this thing would hit this base over here. Okay, so if I start measuring at 20 and I want 2 centimeters, wouldn't I go to 22? Okay, so this is 2 centimeters. And then the last thing left to do would just be to connect this here. And I'm going to make sure that this measures 2.6. Roughly, I've got about 2.7 on mine. Okay, so I just duplicated. This triangle is the same as this triangle. I just duplicated to the best of me being a human. All right, so now I need to blow this thing up by 2. What happens to the angles when you blow up or shrink? They stay the same. But what happens to the side lengths? They need to be multiplied by 2. Okay, so I'm going to go ahead and do an 8 centimeter. An 8 centimeters. So I'm going to start at 0. Let me see if I can scooch this up and not be, 8 centimeters from there to there. Okay, so that was 8 centimeters. Okay, I need a 38 degree angle from here. 38 would be like here. Okay, and again, I need a 4 centimeters here because I need to blow that up by 2. Okay, I'm just making it just through those dots down there. Okay, so somewhere here is going to be 4 centimeters. I'm going to measure that right now. And again, I'm hitting this base. So I'm going to measure this at 20. And I need to go to 24 for 4 centimeters. 4 centimeters. Okay, and this was, I just measured that to be 38 degrees. Okay, now, and now I'm forgetting, I think it was that dot, not that dot. Yes, it was. And then I'm going to go ahead and connect this. Okay, and I need to make sure that this length is twice 2.6. So it should be 5.2. Okay, it's a little longer, but to the best of my human ability, okay, I doubled that, 5.2 centimeters. Okay, so there's my duplicate, guys. I should say my duplicate and my blow up by 2, scale factor of 2. All right, number 16. If the ratio of triangle HIJ to triangle KLM is 4:3, here's HIJ down below here, draw KLM. Okay, the ratio, which one's the bigger, which one's the smaller? Okay, I hope you're thinking that the 4 goes with HIJ and the 3 goes with the KLM. If we're talking ratio, the order of these is the order of these. Okay, so what is the scale factor of HIJ to KLM? Okay, so we're shrinking. We are shrinking this image. So we're going to have the 4 and the 3. Is it going to be 4/3 or is it going to be 3/4? Which way would shrink? Remember, shrinking needs to be smaller than 1. Okay, do I think KLM will be bigger or smaller than HIJ? It's going to be smaller. And then it says explain. Okay, so I'm going to say something about since the 3 corresponds to triangle KLM in the ratio, and 4 corresponds to triangle HIJ, that shows triangle KLM to be the smaller one, to be the smaller one. All right, so let's see here. We've got 1, 2, 3, 4. We've got 4 here. I'm going to just mark these. 1, 2, 3, 4, 5, 6, 7, 8 here. Okay, and this is kind of like a question mark because it's on an angle. Okay, but if we get this and this done over here, we can definitely get that third side. All right, so 4 times 3/4, that comes out to be 3. So I want 1, 2, 3. Okay, and then we're going to take 8 and multiply, I'm going to scooch up, and multiply it by 3/4. That would be 6. 1, 2, 3, 4, 5, 6. Okay, I'm going to get a ruler in there to do this one. That one's not as easy. All right, so this was 3 units, this was 6 units, and we need to label this. If this is HIJ, this is KLM. All righty. Next page. The ratio of triangle ABC to DEF is 5:4. If side length BC is 15, what is the side length of EF? You may need to draw a diagram. Yeah. A, B, C, D, E, F. Okay, BC is 15. What is the length of EF? All right, let me show you how we're going to do this problem. Okay, so we are going to take and make a proportion. We've done these before. Okay, so if we know that ABC to DEF is 5:4, 5:4, so we've got the big one on the top, the little one on the bottom. Okay, this is the big one. Okay, don't go by the looks, but you know ABC goes with the 5 and DEF goes with the 4. That makes ABC the big and DEF the little. Okay, so we've got big over little. So BC goes with the big one. So there's our proportion. Okay, and you know from a prior lesson that how to solve these. Okay, so we're going to cross multiply this. So 5x, and I'm going to come up here, I'm kind of out of space, equals 60. Divide by 5. and you've got 12. Okay, so EF is 12 units. That's our answer. Okay, use the figures below to answer the following questions. Two triangles are scaled versions of each other. Use a protractor to find the measure of each of the angles of the two triangles and label them on the drawings. All right, I did not do that when I did my original lesson here. It looks to be about 46. And this one looks to be about 55. Okay, and remember, these should add to 180. Okay, and then this one comes out to be roughly 80. Okay, and if you take a moment and just add those up, you better be right about 180. Okay, and remember when we're humanly measuring 3 different angles, you might be a degree or 2 off on each one. So if you're anywhere from like, say, 75 to 85, 175 to 185 total, you're good. Okay. All right, this guy. Okay, if these are scaled versions of each other, shouldn't they be the same? So I'm getting 46 here. Okay, I'm getting 55 here. And then this guy. I'm getting right about 80 on that one as well. Okay, so all the angles stay the same. Okay, it says, what is the ratio of triangle ABC to XYZ? So we're looking for a ratio. This one's the small one, this one's the big one. Okay, this one's the small one, this one's the big one. ABC, I'm going to take either one of these, 6.4, and I'm going to put it over its corresponding 9.6. That simplifies to 2/3. What do you have to multiply the sides of triangle ABC by to get to the sides of XYZ? Okay, so if I multiply this number, okay, remember we're blowing up. We need a number bigger than 1. So our number is either going to be 2/3 or 3/2. Common sense, if we're blowing up, needs to be larger than 1. Okay, that is called the scale factor. What is the relationship between the ratio and the scale factor? Remember we talked about they are reciprocals of one another. What is the ratio of triangle XYZ to triangle ABC? So going from the big to the little, don't we need something smaller than 1? So it's either going to be 2/3 or 3/2. So 2/3 XYZ. Oh, hang on a second. Ratio. Sorry, guys. I thought it said scale factor. Ratio. XYZ. XYZ is the big one. To ABC is the small one. So 3:2 is the ratio. And then what do you have to multiply the sides of XYZ by to get the sides of ABC? Okay, here's where we're shrinking the object. So is it 2/3 or is it 3/2? It's 2/3. Okay. Last one. All right. The pair are proportional. Use a proportion to solve for the missing sides. Okay, hang on one second. I'm supposed to meet somebody at 8 o'clock in the morning and it's 8 o'clock. Let me just let them know I'll be right with them here. Okay, I'm just going to keep an eye out for when they join. Okay. All right, it says to use a proportion to solve for the missing sides. Okay, we've got big and we've got little. It says that they're proportional, so there's a relationship between them, so we're setting up a proportion to solve them. Notice we've got two unknowns, R and P. Okay, what we do know the relationship to be between them are those pink circles. Okay, so we know big over little would be 5 over 2. And then we're going to do big P over the 7. Okay, that one relates to one another. Okay, so we're going to use this big over little equal big over little. And then we're just going to solve this. So we've got 2P. Remember, we cross multiply. 2P equal 35. Divide by 2. And we get P equal 35 halves. Okay, or 17.5. And remember, we need some sort of units. This doesn't have centimeters or inches, so we know that it's units. Okay, all right, now for the other guy, we're going to still use the relationship 5 over 2, big over little, but this time we're trying to find and solve for R, the missing side R. 8 corresponds with that. So we're going to go ahead and cross multiply. Got 2R equal 40. We're going to divide by 2. And we get R equals 20. Please make sure you have that units by there. It's some sort of a unit. Okay, this number 19 is very important. You will see it quizzes, you will see it tests, and you'll definitely be seeing how to use proportions in solving problems in the future. A very important concept. Okay, thanks guys.